Gabriel. Once again, Laura to the rescue.
Okay. Thank you. Okay. Thank you. So we need to create the container image, which is kind of the template for the containers, which are then the objects that we are running. To do that, we need to use a Docker file. And the Docker file is nothing else than a set of statements that declare what all goes into an image. An image is a layered thing. It's like a stack of layers that you build up, and each layer does some changes in a file system. Now, we are talking here about the union file system, how this image is built up. So when you have on the ground layer, you have a set of files and how they are structured. Then you put on top of it another layer which has some delta, some added file. And then the union file makes this from, as the end result, it's a merge of these two layers, where the topmost layer overrides what the lower layers were. So that said, this is a typical, very simple Docker file, how you would actually author it when you are having a node application. Usually you don't start from scratch. Technically you could. No, you could say here from scratch, and you would have basically nothing, and then you would have to install a hell lot of libraries and whatever, depending on what kind of application you have. But that's tedious, and there are better people, the experts, in this case the node folks, that have created and images that they curate, that they are also scanned by Docker for security vulnerabilities and the like. And my advice is always use one of these curated images as your base. In this case, since it's a node application, I'm taking the node image and I have the tag latest here. Again, this would probably not be the best thing to do when you think about the production-ready application, because there could be surprises when you take always the latest and greatest version. It could technically break backwards compatibility. So often you put here a tag, for example 7, to say I want node 7, or 7.3, I want node 7.3. If I only say 7, then it's the latest of the 7, major version 7. It could be 7.6.5 or something. If I'm saying 7.3, then it's the latest of 7.3. It could be 7.3.11 or so on, or you can even go more specific. But for the moment, let me do the latest. Then I do my own stuff. I have a copy command which copies actually the current directory with all its content into an app folder inside the container. Then I'm setting the context inside the container to this app folder. And as always you do in a node application, you run npm install, which looks whether there is a package.json in the current directory, and if yes, looks into it and finds out what it has to install. And finally, I have the last line is the start command that will be executed when you actually create the container. These commands all make up the image. The last one these are executed at build time, and the last one is executed at runtime. That's important. Okay, now I have this thing, and now I want to build my image, and for this I go into my console, and I can just do Docker container build, That's the build command. And for the oldies here in the audience, they wonder what the heck it was Docker build. Why does he do Docker container build? This is the new syntax, which is highly recommended you use. It's much more clear, and eventually the old one will eventually, in the far future, but still eventually it will be deprecated. So it's about, and it's even not right, I'm making a mistake. I'm not building a container, I'm building an image. So sorry for that. Then -t is telling me what name should this image have. And normally, usually, you give it the username of your Docker store account, former called Docker Hub. Since a few months, we have everything called Docker Store. My account is Schenker there. Then the image name, let's call it pets node. And that's it. I need to also give the context where and what I should build. So I'm saying, just look into the current directory, and what it does, it builds my image. That went really fast, and the reason is because I had already built it previously. So to show you how that would look like in reality when you build the first time, I do just a no cache, and then it takes a little bit longer because it does this npm install now, which, as you know, might take a while, but it's still quite fast. So now I have this image, and if I do a Docker image ls to list all my images, unfortunately I have a lot of them here on my laptop. You see I play a lot, but this is my Schenker pets node. And although I didn't specify a tag, it automatically got latest. So whenever you don't specify a tag, it gets the tag latest. Okay, cool.
And can you repeat this question on the mic after I ask it for the audio? Is there a particular reason you didn't go with the node Alpine image?
The question was, is there a specific reason why I didn't go with the node Alpine image? That's a very good question, and I have to admit it's pure laziness of myself. There is no specific reason here because my node application is very simple. I do not have some weird libraries that might not run on Alpine. So I could save a lot of space because, as you might all know, Alpine is significantly smaller than the other Linux distros usually that are around. So the Alpine, the barebone Alpine is about only 8 meg if I remember correctly, and then of course my own node libraries would still add a little bit, but it would be significantly smaller than my 664 meg. I would maybe be 150 meg with the Alpine, maybe, because Node still uses lots of. But it wasn't. That's a good optimization technique. Thank you. Okay, so and now we can actually run this little application, and it's a container that we want to run. So its old syntax was just Docker run, but now the new one is Docker container run. I'm saying this means when you're done container, when I don't need you anymore, remove yourself and don't stay in the around and occupying precious resources. -IT means interactive, run this container interactive with an attached terminal, so we can actually see the output of standard in and standard out, standard out and standard error. Sorry, and I need to also, since I'm listening, since this is a web service or an API. You saw it's going to listen at port 3000, but the container is an opaque thing. It's like a sandbox. Normally from outside, when I'm using the browser, I cannot peek into it, except I'm poking a hole into this container, like I usually do on a firewall. So by default, containers are perfectly firewalled from the outside. So I'm poking a hole, and here with this syntax, I'm saying, hey, map the container port 3000 to the external port 3000 of the host. I could here put 5000. Oh, sorry. I could put here any available port, so they don't need to match. And finally, I'm saying my image name. Okay? And you saw it started up. It executed this command that I had defined inside the Docker image, which was npm start, which would look exactly the same if I had run the application on the host. And I'm running on port 3000. And if I'm now going here and actually go to localhost 3000, yeah. Okay. So I'm seeing that there is something, unfortunately. Oh yeah, now it's coming. For our cat lovers. You see, this is served now from a container. You can also see what the host name of this container is here. It's a weird ID, which is okay because containers are not to be treated like pets with a nice name. They are like cattle. They just have an ID. Okay. Any questions so far? And that's really that I'm not cheating is I'm stopping the container and I'm trying to refresh here. So that was really live, huh? Okay. Now.
What options there on that command to be specifying what type of network configuration you want to connect to the container, like network address translation or bridge switch or?
Yeah. So by default. So when you do a Docker network ls, you see what kinds of networks are available on this particular host. And by default, I'm using a bridge network, which is here on this host, which is not able to go across hosts. When I then talk about the swarm, we will use the overlay type network, which will automatically be created when I'm creating a swarm. Mm-hmm. You could also use the host network, which would basically map to the host's network stack, which is not recommended you ever do in production. It's just for very special usage scenarios. Okay. So now we want to go to the swarm, and to be able to run on the swarm, I need to push this image to a registry. I will push my image to Docker store, and then it will be available anywhere from which you have an internet connection. So let me do that. First of all, to do this, I want to tag my image. I want to give it a specific tag. And that I can do Docker image tag, and I need to give him or it the name of the image that I want to tag, and then the full name, the fully qualified name and tag of the target. So meaning that I'm now tagging the latest to version 1.0. Okay? So that said, now I can do a Docker push and push that patch node 1.0 to Docker store. It works for me because I'm already logged in. If you get an authentication failure, that would just mean you needed to log in. I'm using my private account. I could also use some team accounts. Now, when you're working in a team, then you usually don't store it in your private account. Yes? Say it again.
The private accounts, they aren't scanned for viruses.
No. These free private accounts are not getting scanned. All curated images, so-called official. It's not that we, Docker, curate them, but our partners, like Oracle or IBM or MySQL or whoever, they curate these images and we take them as official images and we scan them as a special service to the community. Okay. Now I have pushed this to Docker Store and I can actually go and search for my image. So I go store.docker.com. That's our new store. It's live since about 1 month now. Docker Hub is still alive, but eventually will be decommissioned. So if I'm now searching, hopefully, Pet's node here. Let me see. And here it is. You see that I have actually, I can view all versions that I have, and I have a version 1. I also have a version 2 because I played already with it, and I have a latest version. These are now available. These are public images, and so they will be available. So now, basically, we are ready for the swarm. But before I do some more coding, let me go and talk about some background about the swarm. Here is a picture of the swarm. Sorry, it's a little bit small, but swarm is basically a set of nodes on which on every node runs a Docker engine, to be precise. That's all what it is. And then we distinguish 2 roles that the node can have, and the node is either a physical server or a VM. It can be a very beefy one, or it can be your Raspberry Pi, if you want. So you can create swarms of Raspberry Pis just very nicely, and it's running wonderful. We have one Docker captain, Captain Alexis. He is a very fan of Raspberry Pis, and he makes a lot of tremendous examples on it. So it's always interesting what's possible. We also run on, in the meantime, IBM has ported Docker to their mainframes. So we run from mainframes to IoT devices, which is really cool if you think about it. Okay, so we have manager roles. Managers, they are in what's called a Raft consensus group. That's not something we have invented. That's just a way of having a consensus or achieving a consensus between multiple parties, for high availability. So if one of them dies, there can still be made decisions. This consensus group is a synchronous thing. All need to agree of an operation, and only then it's successful. And then you can also see why there is a fine balance in the number of managers that make actually sense. So I wouldn't say that you should scale up to hundreds of manager nodes. That would be silly. Then you couldn't do anything on the swarm anymore. Normally it's between 1 and 7. 1 is for development purposes when you don't need high availability. 3 is for small to medium-sized swarms, and then 5 is for medium to large, and 7 is for very, very large.
The manager group, is that they all be close together? Or is there some...
Yes, they should not be across data centers for sure. They should be in the same data center, but it makes sense not necessarily in the same rack or in this, yeah.
And are they all active?
They are, yeah, there is one leader, but they are all, basically the leader, they are all somewhat active, but the leader makes most of the decisions now. Okay, then the workers, there you can have thousands of it. I just got to know that, for example, CERN, you have heard about this particle accelerator in Switzerland. They do gigantic swarms of thousands and thousands of nodes. They actually love Swarm, which makes me, of course, really happy. They also use Kube and Mesos, but they seem to like the easiness of Swarm. Okay, the workers, they are there to actually handle workload, your applications, your services, and they exchange information, metadata about their state in a so-called gossip network, which is eventually consistent. Okay, so now that's about it from slides perspective. Let me go back to the console, or actually, I will do something really fun. You might have already heard about it. I will use Play with Docker to generate my swarm. It's a very fun way to show you what the swarm is all about without having to do a difficult installation, let's say in AWS or Azure or Google Engine and so on. So let me go to Play with Docker. First, I have to say that I'm not a robot. And then I'm getting this interface. And here, what's cool is that I can provision my nodes with a click of a button. That's always been my dream. And we are getting there. So we are close to it at Docker to provide these features on production-ready environments. But you have to, surely you will hear a lot of very interesting stuff at DockerCon. But so far, for our purposes, I am completely well with this Play with Docker. So you see what it did. It created me an instance, a node, called it node 1, gives me a terminal, so I don't have to SSH into it. I just have a terminal and I can right away hack on it. It also has an IP address. This is an internal IP address, but it's still very useful. All nodes can communicate on this network. No, what I'm going to do is initialize a swarm, and it's as simple as that. I need to tell on which IP address I'm going to advertise. And this is just this IP address. Okay, so now I have a swarm, and you see it because I have this symbol here, and it's filled out. That means it's actually a master node. It's a one-node cluster. Oh, hopefully. I hope this will work, actually. This terminal is not the best one because it's running inside the browser. So,
So the first step was creating the infrastructure, right?
yeah, exactly.
Outside of the Docker.
Exactly. Currently, it's still outside of Docker, but soon we will make that much easier. For example, we have a product called Docker for AWS, and Docker for Azure, and Docker for Google Cloud. And these are similar to the editions that you know from your client machine, Docker for Mac and Windows, with the big differences. They are meant for operations guys or gals that actually want to provision swarms. So these, for example, Docker for AWS uses CloudFormation template, And the same with Azure uses the Azure Resource Manager templates, I guess it's called.
For operators to set up the
Infrastructure, load balancers, and so on, and security groups, and you name it. Yes?
Does Docker run directly on ESX or Hyper-V?
We are working closely. Yes, Docker Enterprise Edition runs. Our goal is to run on-premise as well as in the cloud, and even hybrid. So we are having a collaboration with HP to run on bare metal, for example, on-premise, and HP. And we having a huge partnership with Microsoft to run on their on Hyper-V and in on-premise infrastructure and in their cloud Azure. Yeah.
So I was surprised you didn't mention Docker InfraKit. So why not?
Docker InfraKit is not yet GA. We are still working on it. InfraKit is the tool that actually will be used to provision infrastructure. It's going to be used for the first time in our own products in the Docker for Google Cloud. It's kind of an abstraction layer on top of the actual implementation details of the respective cloud provider, so that you can define your requirements, basically a set of nodes in a scaling group, auto-scaling group, load balancing, and so on in a cloud-independent way. Yes?
So, since I'm new to this, is it fair to describe it as a quote-unquote opinionated CloudFormation or a Terraform?
It's a kind of Terraform.
Specifically for if you're running Docker.
Exactly. It's Terraform's idea, opinionated. Exactly. It's all declarative. We do not code, no scripts, no nothing, everything declarative, which is really nice if you know if you have been scripting your way. Okay. So now I have a one node swarm. I can do a Docker node ls, and I will see that I have one node currently, and this is a leader node, as you can see here in the last column, and it's active, this node now, and it's called node 1. So now you also saw that here I have this interesting command here, which I can use to join other nodes to this swarm. We are using tokens. That's the only way you can actually join a swarm. Swarms by default are highly secured. We only and exclusively use transport layer security, TLS, mutual TLS. So everything in transit is encrypted and safe. We are using, we are having our own CA certificate authority with self-signed certificate. Sorry, difficult word. But you can bring your own CA and integrate it with our Docker Swarm. And that's actually the recommended way. We just wanted to give you something very secure by default.
So far, all you did is initiated a single
Exactly.
swarm, and it's not a hybrid, means it's only manager, so it technically doesn't work by itself.
Manager is also a worker. Although in production we recommend not to do workloads on managers.
But right now, you could deploy workloads.
Exactly. A worker is not the manager, but the manager is a worker. Okay. Okay, now I can go and add another instance by just clicking here. And you see I have another terminal. It's called Node 2. It has the next available IP address in the subnet 13 here. And I just need to run this this cryptic. Okay, now I lost this command, but don't worry. I can just do Docker swarm join token. And since we have two possible roles, I want the worker join token, which is this guy. And I can copy this one. Hopefully it works with this terminal now. Okay, and you saw how quickly that went. It's already joined, and shortly you should see it that here will be the symbol. Oops, no.
We didn't copyright from the.
Okay, that's the. Let me do this one. Okay, so just I will increase. I'm sorry for that. It's not the best terminal, but it's an awesome product, so I shouldn't say anything about it. So, okay, this node joined as a worker, and you see here that it has this symbol here. And let me create another 3. So we will have a 5 node swarm. Unfortunately, I cannot have more than 5 nodes here, but that's only to play with anyways. So let me join this guy, and join this guy. So you believe me that to create the swarm takes me less than a minute? Even I can create a swarm on AWS in less than 5 minutes. Or on VirtualBox or wherever. So it's really cool. And now I can go back to my, oops, that was a little bit too much. Is it okay like, Okay. So now if I do Docker node ls, I have my 5 nodes. Still, all 4 are others that I just joined are workers. I can now promote other nodes to manager status, and I do that. Docker node promote, and I do node 2 and node 3. Okay, they are now both masters or managers, and you see that by the status they are now having, it's called reachable, so they are followers, and we still have node 1 as the leader. So now I have my highly available swarm. I only have 2 worker nodes. Of course, I can scale it up at any time, not in Play with Docker, but in AWS or wherever. I can just by adding more of these nodes. So, and now we can go and run our Docker container here in the swarm, and I can just say run. You remember I do exactly the same command that I had before. Was it 3000? I guess, yeah. And then Schenker at pets node 1.0. Okay? Because this image doesn't exist locally, it pulls it here, which takes a moment because I had unfortunately taken the fat image, not the node Alpine. I'm punished here. This stupid terminal. I cannot even scroll it, so.
Remember, it's being recorded.
But you see that it was actually, it's actually here, started. And another interesting factor, look at this nice badge here. Play with Docker automatically recognized that I have a port 3000 on my host now. And I can click on it. This is a link, and it will open me the application directly. Okay? That's really cool, and I can refresh or watch all these nice pictures. But Actually, that's not how you normally use a swarm. You don't normally start individual containers on a swarm. That would be silly. On a swarm, we have the concepts of services. Because what happens to a container? If a container is dead, Who knows about this? You would have to have some kind of infrastructure to know about it. It's just, otherwise it just dies. But services are a concept which actually are the blueprint for what you want to run. And it defines what image you want to run, how many replicas you want to run, and a lot of other interesting parameters. And that's exactly what we want in a swarm. We want to have high availability, not just of the infrastructure, but also of the applications. So when a container dies, the swarm manager will realize that and start a new instance. And remember, containers have to be treated not like pets. We are not going to bring it to the animal hospital. If it is sick, we kill it and throw it away and get a fresh copy of it. We don't ever patch a container. We throw it away and get a new copy of it now. Yes.
So when you started that container earlier, is it because it's running in a node that is swarm aware, but it's not running through the swarm?
Yeah, it's running. I mean, a swarm node is still like a regular node. I just wanted to prove, basically, I can now pull this image because I had previously pushed it to the registry, to Docker store, and I can run it on my swarm. But
so there's no scheduler, right?
no, there is no scheduler. That's using.
On node 1, it's on node 1.
Exactly. Yes.
So you mentioned throwing containers away and building new ones. So in the VM world, you can take snapshots, so it's kind of like an instant backup. Does the same concept apply in a container?
Containers, so images are read-only, immutable. So that's our snapshot. And containers, they have a writable layer on top. Whenever you create an instance, a container, you create on your union file system a writable layer. But this is specific to that container. When the container dies, this layer goes away. Otherwise, the lower layers are all immutable. And if you need to persist data, then you need to use volumes or databases.
So LXC does have a snapshot capability. Containers, as opposed to Docker, has the snapshot.
I know that these LXC containers exist, but I'm by no means an expert on them. So,
But you can still checkpoint the containers.
sorry, one at a time. Sorry. Yeah.
We still have feature to checkpoint the container.
What you can do is commit the container into an image in its current state. Yeah, but that's not what you usually do.
I'm asking about Docker checkpoint command. It used to be there in one
Sorry.
Yeah, I was able to checkpoint and restore boot and
Okay, you had a question too. Oh. Okay.
What's the reason behind the question? What are you trying? Is it live migration? What is it? What is the reason behind it?
just instant backups, just prove things.
Okay, so what I'm now creating here, and I'm really hoping you in the back seat can see it too. I'm creating a service. I'm naming it with a meaningful name, Pets. I'm also poking a hole, basically, or publishing a port. And this is a little bit different now than the publishing before. When I only dealt with containers, then this had only to do with the current host on which I was, and outside of that host, nobody knew about this thing. Here I'm publishing the port globally in the swarm, and we will see in a minute what that actually means. I'm also taking the same image that I used before, and I don't specify how many instances I want to run. By default, it's one instance. So I'm running this, and now you saw that immediately again here this badge appeared, because this application recognized that there is a published port on this particular host. And I can click it, and I have again my cat. No? So, and pay attention of the URL. It's this 13.3. That's my internal IP address, 13.3. Now I go to another node. Let's say node 5. And look at this. It has also this badge here. I didn't run anything specifically on node 5. Maybe actually what I need to do to show you where actually this container, this single instance got deployed to. And for this I have the Docker service PS and the name of the service. And I see that it was deployed on node 1. Okay, so this container is running on the node I'm in, and I can say Docker container ls, and I should find this container. And let me go back to node 5 and do a Docker container ls, and oh, there is no container, but what the heck is this badge here? Let me try it. Interesting. I can run the application, but the URL is definitely not the same, no? So it's 13.7, and the other one was 13.3. I can do this on every single node. This one, and so on. I guess you believe me that this is what we call a mesh, routing mesh. We are using Linux's virtual IP server to handle this, and each node of the swarm, when it gets a request to the particular published port, it finds out automatically where are nodes which have this container instance deployed, and since there can be many of them, it does a round-robin load balance and forwards the call to the respective node. So I can do like I can do a curl here now, localhost 3000. No, I'm querying localhost. I'm on the host. I'm not in a container, and it gives me the answer. It goes actually with this virtual IP server. It realizes, oh, that's not here. I need to treat it. I need to go and look for actually where a real container is, and I even need to load balancing it. Yes, at the moment this is still the single container.
Many people hitting it. They're just being redirected onto that same host that's serving.
Exactly. So we can see that when I'm refreshing, here is, if I'm doing that a little bit bigger, it's 409, and I'm refreshing it. It's always gonna be 409 because it's the same instance. Now what you're referring to is I want to scale this service, and I can do that from any manager node. All these operations that I'm doing need to always be done from a manager node, but I can do on any. So for the fun, I will do that from manager number 2, and I can also first look what services I have. I have this pet service, so I can now say Docker service update, and I say replicas 3 of the pet service. Okay? And then I do a watch Docker service ls. And you see I have replicas 1 of 3. No? And if we wait patiently a while, because it needs some time to download the image, maybe I can do this one instead of... This is a little bit more interesting. So you see that on node 1, I'm already running since 4 minutes, and in the meantime, node 2 and 5 have also gotten their instance and are running now happily. And now I'm going here back to this one, and I'm refreshing. The existing one was 409, huh? And it's still 409. It might take, yeah, now you saw, now it changed, C50. It has, sometimes it's a caching thing, I haven't. So C5, Okay, this is definitely a play with Docker thing. Normally, it makes a nice round robin, and it goes just around the loop now. Yes?
You mentioned round robin. Is there any other alternative?
Not that I know of at this time.
But in a production, you would put like a physical load balancer.
Yes, so at the moment, if you just use the swarm, you still need a load balancer in front of the whole thing, which load balances your requests that come from the outside world to probably all manager nodes or something like that, or however you want to do that. So you have still an Nginx or an ELB or whatever, an AJ proxy in front.
But within the swarm, it's always round robin and it's always through your own mesh.
Exactly, the so-called routing mesh. If you're using, and that's layer 4 for the network specialists, that's layer 4 load balancing. When you use our enterprise products, namely Docker Data Center, UCP, Universal Control Plane, we have also a level 7, an application level load balancing, which is called the HTTP routing mesh, which works with the header, the HTTP header, and load balances it accordingly.
It strikes me that in a world where you have many services, you have to manage your port allocation to service. You identify service by a port.
Yeah, that's why I'm saying you need to have your Nginx proxy or whatever ELB, which maps names like I want the cats versus the dogs to ports, yes. But for that reason, we implemented HTTP routing mesh that you then can actually do that automatically. But unfortunately, that's outside of the scope of this talk. I'm happy to come back one day and talk about our enterprise product. This is all open source so far, what I'm saying here. HTTP routing mesh is our closed source. Okay, so I have scaled. Next thing is what I want to show is that I can actually upgrade an image. No, and for that I need to go and cheat a little bit because I don't remember the okay. Where was I? Here. I'm sorry for that. I tend to forget these things. Here, cheat sheet, yeah. Okay. So, when you want to upgrade your services, you have a new release. Normally, you want to do that with zero downtime, no? So we have rolling updates, And here you can see such a command. You can define the update parallelism, how many containers should be updated at the time, and you can define update delays. And then I define the new image that I want to deploy. No, so I'm copying this guy here. Go. This will be a rolling update, yes. So let me copy that and do it again. And I'm actually going to say update parallelism is 1. It will be a little bit nicer to observe. You remember I had version 1.0 installed, and now I'm going to upgrade my application. I have 3 instances of it. I'm going to upgrade to version 2. Okay? So I'm doing so, and you see what's happening. You see that the first one got shut down and the new image is installed instead. And when it is successful, when it is running, it waits 10 seconds and then it updates the second one. You see it's running 10 seconds, and after 10 seconds it started to upgrade the second one. It waits until it's successfully updated or upgraded, and then it waits 10 seconds. So when you will see that it is running 10 seconds, the third one should be updated. So that's zero downtime rolling upgrades.
So during that delay period, it's pulling out of the registry the latest down to the node.
Yes, I'm honestly, I'm not of the team like that has implemented this stuff, so that, I have to admit, I don't know. I assume they are clever enough to pull things while waiting, so, but I cannot guarantee it.
Or potentially pull from your neighbor nearby?
No, we are pulling from the registry. Normally, in an enterprise-grade installation, you wouldn't pull from Docker Store anyway. You would pull from our Docker Trusted Registry, where we provide content trust and security scanning and all these goodies which make the provenance guaranteed and so on. So that you can then also specify that your swarm should only run trusted images, digitally signed image, cryptographically signed images, and the like. But that's our enterprise offerings. Okay, you see, everything is good, everything is green. I have all my nodes are running 2.0. Okay? Good so far? Yes, so we can look at, let's say I am on node, which one was this? On node 1. Can I go and see what's there? Oops, yeah, nice. It's only the running one. The other one has been removed after some time. Okay, so next topic is secrets. A lot of people, and we are actually, or most of the people, they treat secrets really very badly. And believe me, I know about what I'm talking, because before joining Docker, I worked in a company that was actually in the secrets or a security business, and even there, people treated secrets really poorly, just because it's hard, or it was hard, to treat them well. Now you know, oh, can you share the AWS access key on Slack, or have it in GitHub or somewhere in centralized so everybody can find it without hassle? That's a big issue. And we at Docker, as we always do, said that needs to be simpler and really secure. And our secrets are secure. We stand for it. Secure meaning they are encrypted at rest and encrypted in transport. And secrets are assignable to services, and only containers, instances of their service can actually access these secrets. That's a big contrast to, for example, Cube, which also handles secrets, but they are all human readable, and every service on their swarms or equivalent can actually access them. There is no restriction. We encrypt everything and make it only available to the services that are configured for it. And also these services or containers, secrets are only physically stored on manager nodes and encrypted in the Raft consensus database. And in transport, they are encrypted, and on the worker node, they are never physically stored. They are mounted using tempfs into the container and decrypted. So inside the container, secrets are mounted in /run/secrets, which is a tempfs. So when the container goes away, the secrets are flushed and are not accessible anymore. And with role-based access that we offer in our enterprise products, you can secure your containers so that only admins, for example, can exec into containers and possibly see those secrets. No? So we have extremely hardened everything. So let me create a secret, Docker secret create, and give it the name DB password. And a value. The value I can get from standard in. I'm having this placeholder. I'm piping a value now into it. I'm saying the very secure password. So I have created a password. Now I can go list the passwords I have, inspect the password. I see a lot of information, but I will never see the actual value. Okay. I will never see the actual value. Okay. So now I can update my service. Actually, before I do that, let me talk about another concept which is very important with a swarm. Are you guys still good? I know it's been a long time. I don't want to overwhelm you, but if you follow me, I'm more than happy to show you another concept. So I have showed you how to create the service, but normally we want to deploy whole applications, which consist of many services potentially. We call them stacks, okay? So, and stacks, you might already have heard about Docker Compose. Developers use Docker Compose to deploy on their development environment whole stacks, meaning multiple applications consisting of multiple services. For example, a node application with a backend MongoDB and maybe Redis as a cache or whatever. So that is simplified through so-called compose files. And now in the swarm, we are not using Docker Compose, but we are using what's called stacks, and stacks can be fed with compose files or compose-like files. We originally started with the so-called DAP files, Docker application bundles, which were very powerful, but users told us, hey, why do you introduce yet another format? It was so nice, the Docker Compose. We already have them. Our developers have them. Why do we have to migrate? So we came back to it, and now we are also supporting YAML files. Docker Compose files are in YAML. And so I will create such a YAML file, quickly and call it stack.yaml. And it starts with a version declaration similar to what you are used in the development environment, but we have a higher version here. For stacks, it's actually 3.1 is the newest one, and then I'm declaring my services. And let me say I have my application, that's the app service, and I'm using an image for it, and this is my Schenker pets node of version 1.0. I'm declaring that I'm having ports. I'm publishing port 3000. Okay. So that's my stack file, which, of course, here only one service, but if my application would use a DB like Redis or Mongo or MySQL, I can just append here the necessary declarative information. But for the moment, that's enough. Oh, thank you. Okay. VI is such a good thing. I love it. After the year, it took me to figure out how to exit it. But now I love it. Anyway, it's everywhere on all platforms, so it's cool. So let me first remove my service that I had previously just to have no conflicts. So it's gone, and you see also that the badges disappear because there is nothing anymore. But instead, I can now say docker stack deploy -c means which compose file. It's called stack.yaml. And how is my stack going to be called? It's going to be called pets. You saw it started this whole thing. It created a network for me, the pets default network, which happened to be an overlay network because I'm in the swarm. And on this network, I have my application, which runs perfectly fine. Okay. Yes?
When you destroy the service, if you had running does it clean up after itself, or are those Docker images, containers still running, but just not part of this?
No, it cleans up everything.
Not just the networking.
No, we kill. Actually, what we do, we try to gracefully shut down containers by sending everyone a SIG term and give it 10 seconds to gracefully shut down. And if it doesn't react, we kill it. Yes?
Did you not declare the overlay network in the YAML file?
No, that's automatically here for me. I could. Usually, you will have in a normal application, production grade application with multiple services, you will have added isolation and security by declaring multiple networks and only attaching containers or services to them that make sense. So the web front end shouldn't be on the same network as the DB backend or something like that.
When the service is created in the stack, you didn't specify any scaling, so
no, now it's only one. So it's still. Oops. Okay, I'm sorry. Docker service ls. It still created the service for me, and it called it pets_app. No, pets is the stack name. I can run multiple stacks, no, just to show you. I'm not sure about the port. The port might conflict. I'm not sure. Let me not do it. I haven't tried it. But technically, I can run multiple stacks, the same stack multiple times in parallel with different names, and they shouldn't.
you scale every item in the stack. So if the stack
No. You can per service you define. Everything is per service. You can define it in your YAML file.
Your unit of scale is still the.
Exactly.
You have a dot like the pod component.
No, that makes perfectly sense. For example, imagine you have your MongoDB. You don't want to scale your MongoDB just like that. You want to define a cluster. That's really something you want to handy.
But when it have the additional abstraction of the pod that's common in the Kubernetes.
Yeah, I know what you're talking about. Currently, we don't support pods. I know that we are working on it, but at the moment, it's not. Okay, so now secrets. The whole idea I did because I wanted to show secrets, actually. So let me do again this one, and I can now define secrets here. Secrets. DB password. So I assign to my app service a secret called DB password. And then I need to define what my secrets actually are. My DB password is a so-called external secret. That means it's already defined in the swarm, which you saw when I did it. Okay, so hopefully I did remember everything correctly. So now I redeploy my stack. Pets. Okay, it realized it's already running, so it updates it. It uses the delta normally.
Is the process of the update basically first you take the definition of the swarm saying here's my new definition of the stack, and then the thing monitoring will eventually consistent, right? So
Exactly.
decide what to do.
Exactly, it will figure out because the swarm contains exactly. It's all about desired state, and it tries to always approach the desired state. It works really, really hard, the swarm or the managers, to achieve the desired state, and the desired state is what you have in your declaration now of your services.
So because you already had a previous definition that had a single thing running, and now the change you did had nothing to do with that, it didn't touch that container, right? Didn't restart it.
I think it will, some of the changes, I think it's most changes at this time will actually restart containers, but that's no problem because you can define rolling updates. We are working, and there are some customer requests which would us to implement non-destructive updates, but we don't see, I mean, we take it for serious, but it's not the very pressuring thing at the moment. We have so many other things to do. Okay, so, but the interesting thing is now when I'm going to look where my container is it here? No, so Docker service PS and pets up. Where is it? Okay, it had restarted it. No, and it's now on node 3. So let me go here. And yes, it is here. And now I'm going, just to show you the secret, I'm going to exec into the running container, and I can do that with Docker exec. It's an interactive with terminal, and I need to give the ID of the container, or I could use the name. Usually to not type too much, it's suffices to give the first few letters of the ID. If it's unique, and then I need to say what I want to do inside this container. I want the bash terminal inside. So now I'm inside this container. You see here that this is my application, no? Now I can do an ls minus, and I said it's in run secrets. You see that I have a file db password. Secrets are always mounted as files. I can do a cat run secret db password, and I see the content. So inside the container, it's decrypted. So you will create your applications to just use these files, and their content is very simple. They should be stored in the consensus, in the Raft consensus store. But then again, I admit, I'm not 100% sure how exactly the decryption happens.
So, does that mean that administrator can read video secrets with somebody else have deployed?
Well, just in a bare swarm as we see it here, everybody that has access to this swarm can technically exec into the containers, but that's on purpose because Swarm is open source, and we expect other people to build security on top of it, as we do with our enterprise products. If you use Docker Data Center, you have role-based access, and everything is locked down. So you have your teams with your members that have access rights, which are very fine-grained, and other than admins, people usually cannot exec into a container. They can maybe see containers and run them or kill them, or not even that, only see them. So, but Swarm on its own, it's pretty open. No, if you have access to the Swarm, of course, due to the fact that it's secured with mutual TLS, you need to have at least a certificate. So not a hacker won't get access. But if you are a trusted member and have access to the Swarm, you can do pretty much everything. Yeah. Yes.
So the way the secret is distributed, so the manager has the decryption key, so it decrypts it from the state store. Does it send it in plain text over TLS to the worker node, or does it?
I would expect so, but I'm not 100%. I cannot guarantee you that. I'm sorry. Other? How am I with time, Kartik?
It's like 8:30 or 8:22.
Still up for some more? I haven't talked. So regarding the Swarm, that's pretty much it. My next thing would be about the developer workflow, how we can actually decrease friction in the development workflow by using containers. Okay.
Do you have any other topics, or that's your last section?
That's my last section. Okay. Yes.
How do the nodes themselves talk to each other? Not the container, the nodes.
Overlay. So they have this so-called how's it called? So they have their own network they're talking across. Now this I forgot how it's called. Yeah, the type. Yes. Yeah. But the name of the network, not the technology, not the implementation detail, I forgot about. I showed it on the slide. The gossip network. No. But this is under the hood. Okay, so let me talk about, I'm back on my developer machine here, and let me talk about what's my experience if I'm a developer. So, and you saw me you saw me previously running a container. Here I'm running a container, and I can go and actually listen to localhost 3000, where my application runs locally on my host, on my developer machine. So now I want to do a change in the code because I'm a developer. And let's say I want to change the color of the title here, and I do something which every good developer, UI developer should kill me for it, because I'm doing inline styles. Yellow. Let's make this yellow, no? Okay, and now I would actually expect, if I'm going back here and do a refresh, it should show me the title in yellow. Unfortunately, it doesn't do that. Exactly. So now what I have to do is here actually stop my container, rebuild the image. Here is, oh, I shouldn't have to no cache. Next time I do it, at least not then. So let me remove that. Okay, so I rebuild it and I run it again. And then hopefully, if I'm refreshing now, it took my change. That's really tedious, and that's a lot of friction. And believe me, since I have been responsible to implement best practices for developers, I heard a lot of this feedback. Why should we use container? It increases only the friction. No, because they didn't do it right. And so, and definitely we can do better. What can we do? We can volume mount our source code into the container, so that when we do a change in our favorite editor on the host, this change will automatically be propagated into the container, and the container can technically use it. So let's do this. So here I'm going to add another command line parameter called v, like volumes. And what do I mount? I'm mounting the current directory into the app directory inside the container. If you remember, in my Docker file, I had copied all my source code into the app container inside the container. Now I'm running this one. Oops, yes, that's, I know exactly what the problem is. Let me run that quickly and do an npm install here. The problem is now that I have overwritten the node modules folder in the container, because I mounted my host volume. It's basically when I'm volume mounting, I overwrite what's in the container, no? And so, unfortunately, since on the host I didn't have the node modules, they weren't there anymore, and so it said, hey, you don't have Express, or I do not have Express. So now I cheated. I did a exit into the container, run npm install, and because I had volume mounted, the npm modules folder is now also on my host, so that when I mount it, I have it. Okay, so I have this, and now I can go and change something. Let me do this to orange. Is that yeah, it is legal. I'm not the web UI developer, so bear with me. And let me go here and try to oops, that wasn't what I wanted. I wanted to do a refresh. Okay, it had done that. Okay, but actually, it's not quite true that was because I had rebuilt. If I go back to yellow, save. It's not taking it. Why? It's because I'm using mustache templates and apparently these are cached. And so it has no effect. So what do we usually do when we are working with a Node application or a Python or .NET or Java? We use some tool that automatically recognizes when we change our files and restarts the web server. And we can do that, and we can use a tool like NodeMon to do that for our Node application. But now it starts to get a little bit hairy because I'm using development time only tools. And normally I don't want to have this in my production ready image. So I'm starting to work with development time only images, which I use only during development time when I do my edit and continue type of development, which has its own Docker file. I call it dockerfile.dev. And what I'm doing here is installing this node monitor tool globally inside the container. And then I'm using an alternative start command, namely start dev, and this start dev is defined in my package JSON, which does nothing else than using nodemon with my entry file and on the correct host and the port. Remember, for the production image, I only had npm start. Here I'm using this start dev. Okay? So I'm going and create my development time image. So I say Docker image build. But this time I don't use the standard Docker file, but the Docker file with the postfix dev. I can do that by declaring it. The tag should be just pets node dev. There is no need to give my username or a tag, because I will never push this one to the registry. This is a development only image which should never ever go into production. So, and I'm building this. Okay, now I have my image, and now I can do Docker container run rm itv up. Did I miss something? The port and pets node dev. Okay. In the meantime, you should be very familiar with this, and you see it's a different. It has started nodemon, and it's actually observing if there happen any file changes. And let me do such a change, for example, in the server.js file. Let me just do some nonsensical entry. Let me just do a comment here. Not that this is going to change something in the code, but it's just to show you that it's actually restarting. No, this is on the host. Because I have volume mounted, it has actually restarting due to changes. It has restarted my container and I would have the very latest stuff now here. Let me try this whole thing. I think I haven't configured it quite correctly. At the moment, it only realizes changes on JavaScript files, I guess. Let me just try it. Yeah, it doesn't change. It didn't reload, but I can definitely configure that now with some parameters of nodemon. Exactly. So what the whole point about this is, you can use containers, the benefits of containers, yet still have the exact same experience as you're used to when you would develop directly on the host. That includes even line-by-line debugging. I have no time to show it to you, but I could line-by-line debug my Node application inside my container. The code runs in the container, but my debugger runs on the host. It's basically remote debugging. And I have a blog post on that if you search by my name, and debugging a Node application in a container, running in a container. You should find instructions how to do that. Similar for .NET applications or Python applications, Java applications, etc. Okay, that's it, folks. Thank you very much for your patience. Any remaining questions? Yes?
On the stacks, so it's a lot by convention. Like I noticed you didn't have the wrapper because it was one by default. What happens if you change it to 23, the scaling? Is it by default the rolling upgrade? Is that so a lot of convention is built in the...
If you scale up, there is no change. We do not kill existing. So this is not going to affect the existing ones. It will just spin up as quickly as possible the delta. So if I was at 10 and now you say 23, I will just spin up 13 additional instances. We'll distribute them throughout the swarm. Currently, it's the newest release actually is topology aware. You can even specify things like that it should really make sure if your swarm spans across data centers, it should deploy first across data centers and then maybe across rooms and racks, and so that you have the highest possible availability. You can all specify that, but you have to declare that with corresponding parameters. You can all declare that in your YAML file. Yeah, I wouldn't, I mean, if the data center is really close, it's all a matter of latency because the Raft consensus is synchronous, whilst the workers are asynchronous. So I don't care whether you're a few milliseconds later updated about what kind of new services have arrived or whatever.
You have 10 gig and you have under 1 millisecond latency, you're okay to...
Yeah. Not geographic. I mean, there is the speed of light limit. So if you have, I guess, the light needs about 100 milliseconds. A second to the moon. So light, that's 300,000 kilometers. So 100 milliseconds would then be 30,000. No, that's the speed of light. So even from here to New York is certainly 10 milliseconds, and